Algebra 6.5 notes. We are moving on to linear inequalities today. This is going to look a lot like what we've been doing for 6.1, 2, and 3 with substitution, elimination, and graphing. However, it's going to be inequalities this time, which means instead of an equal sign, we are going to be using a greater than or less than, or greater than or equal to, or less than or equal to. So it will just take the place of that equal sign. Otherwise, it's kind of the same stuff. So I just want you to start thinking by looking at this first situation. It says you're buying paperback and hardcover books at a book sale. You can spend at most $20. So it's not equal to $20. You could spend any amount up to $20 at most. What are the possible combinations of paperback and hardcover books that you can buy? So in your explanation, we're just kind of going to talk through this, and I know this is a video, so you're just going to listen to me talk about it. But what it means is you can start multiplying 250 times 2 times 3 times 4 times 5 times 6 until you reach that $20. And once you reach the 20, that's the most of just paperback with zero hardcover. And then we can flip it and say, okay, well, 450 times 1 times 2 times 3 times 4, however many it's going to be until you run up to $20, and it'd be that many hardcover and zero paperback. Then you could do a combination of 1 paperback and 3 hardcovers or whatever. I mean, you'd have to do the math and see. But for that reason, we don't always have a number that's exactly equal to a situation. Sometimes it's greater than or equal to or less than. For example, this one would be less than or equal to $20. So we're going to do some of that today. So let's look on the rest of the paper. A linear inequality in 2 variables such as y is greater than x minus 3 can be formed by replacing the equal sign, which is exactly what I said earlier. Instead of an equals here, you're going to have a symbol. A solution of an inequality in 2 variables is an ordered pair that makes the inequality true. So kind of like before when we put 2 lines on a graph and we found where they intersected and we kind of gave it an extra little bullseye, it's going to kind of be like that. So an ordered pair that is on both of the lines or on the correct side of both of the lines, as we're going to find out less than or greater than. So let's look at part 1, identifying solutions to an inequality. So is the ordered pair 1, 2 a solution to this inequality? So here's how you would do it. Obviously 1 is my x coordinate and 2 is my y coordinate. 1 is my x, 2 is my y. So then I'm just going to rewrite this and plug in x and y for what they are. So it would be 2 is greater than 1 minus 3. So then you're just going to solve it. 1 minus 3 is negative 2. And 2 is most definitely greater than negative 2. So this is true. So if it is a true statement, then it is going to be a yes. So if it is true, yes, 1 comma 2 would be a solution to this inequality. Is it the only solution? No, but it is one of the solutions that works for this inequality. Okay, so let's try B. Plug in negative 7 for my y, negative 3 for my x, and solve it. Negative 3 minus 3 more is negative 6. So it is saying, is negative 7 greater than negative 6? And no, it is not. Greater negatives are actually smaller. So that means that negative 3, negative 7 would not be a solution to this particular inequality. All right, this is a good time to pause the video and try these 2 on your own. If you're not quite ready, I will go ahead and work it out with you now. I'm going to switch pens because that one's not working very well. All right, 610 is my new coordinate to see if it fits, to see if it works. So we're going to do 10 is less than or equal to 2/3 times x, which our x coordinate is 6, plus 4. All right, 2/3 of 6. Always check on your calculator. 2 ABC 3 times 6 is 4. So 4 plus 4 is 8. Is 10 less than or equal? It could be exactly equal to 8. No, it is not. 10 is definitely more. So this is a no, so that does not work. And then on B, let's try this real quick. 2/3 times 3 plus 4. Again, check on your calculator. 2/3 times 3 is 2. I'm just going to go ahead and tell you. 2 plus 4 is 6 exactly. So let's take a look at this situation. It's saying, is 6 less than or equal? This is or. It doesn't have to be both. Obviously, that wouldn't work. It just has to be less than 6 or equal exactly to 6. And it is equal exactly to 6. So that makes this one true. All right, now let's move on to graphing. Graphing is actually going to be pretty easy if you were good at graphing regular lines. So this is very, very, very similar. So you're going to pretend that it's an equals at first. So for right now, let's just say it's y equals x minus 2. So first start by putting a dot on your y-intercept, which is -2. And go ahead and count slope, which is a hidden invisible 1 over 1. So this is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, now stop. Do not draw your line through, because here is what makes it not an equals. The type of line you draw is going to be a boundary line. And the boundary line could be solid, so I could draw a solid line through it, or it could be dashed. If you want a little preview of what a dashed line looks like, flip to the back. See these dashed lines? Or it could be a solid line. So here's how you determine whether it's solid or dashed. If it is less than or greater than, the line is dashed. If it is less than or equal, or greater than or equal, it is a solid line. Okay, this is really important. You need to really pay good attention to this. And the reason it's dashed is because if it's not exactly a number, if it's just less than that number, then it can't be on that coordinate itself. It has to be only less than that amount. So it's kind of like the same as back when we would draw, let's say our number landed on 4, but it was only less than 4. So it's not 4 itself, it's only less than 4. Back whenever we worked on this earlier in the year, shading on a number line, you wouldn't shade it completely in. That's the same kind of idea here. So we're going to make a dashed line showing it can't be 4 itself. It could be only less than, so we'll dash it. And then same idea here. If it was 4 on a number line and it was greater than or equal, sorry, that'd be this one, greater than or equal, you would fill it in, showing that it could be on 4 itself. So that same type of idea is going to apply with our boundary line on a graph. So since this one is y is greater, it is going to be dashed. So when you draw in your line, be sure that you just do dashed lines in between here, not a solid line. And then we have to decide which half plane to shade, because I want to represent everything either on this side or on this side of my boundary line, and I need to determine which side I'm going to shade. So it's telling us to pick a 0, 0 and try it to see if it's a solution. That's one way to do it. In fact, I'll teach you that way first. So pick 0, 0. Plug it into this and see if it works. So we're picking 0, 0. I'm just going to mark it showing which side we picked. It would be on the above side of our line. So let's pick 0, 0 and let's plug it in here and see if it's a solution or not. So 0 is greater than 0 minus 2. If you solved it, that would be -2. Is 0 greater than -2? 0 is greater. This is a yes, which means that 0, 0 needs to be part of the solution. So we know that 0, 0 is not the only solution, because there's a lot of answers when you say something that's just greater. So 0, 0 is part of the solution, which shows us that this side gets shaded. So none of these would work. And if you don't believe me, pick one and try it. Pick 4, -4. and plug it in and try it. 4, -4. And when you solve it, it's going to be a no. So it should not be shaded because that is the part that is not represented by our solutions. This shaded part represents all the solutions that do work. Okay, and now I'm going to show you just a tiny bit easier in my opinion. Maybe it's not easier to you. Maybe you should pick 0, 0 every time. And if it's a yes, shade that part. And if it's a no, shade the other part. To me, I'm just looking at it and I'm talking about my y-axis here. So look at just the y-axis. If this says y is greater, think of what the word greater means to you. Does it mean bigger or smaller? To me, it means bigger. So I look at where my line is on the y-axis and I want to shade everything bigger, so going up. So that to me told me I was going to shade above. If this was y was less, then I would have gone to my line on the y-axis and I would have shaded everything below it because below it is less. So it is up to you whether you want to pick a 0, 0 and try it out every time, or whether you just want to read the symbol and see if you can make sense of it yourself. So I'll keep reiterating this so that you can figure out an easy way to determine which half plane to shade. But that's kind of how I do it. Okay, so let's flip it over to the back and try to go ahead and graph a few of these. Remember, we're pretending at first that it's an equal. So you would first put your dot at 1 on the y-axis. Our slope is -1/2, so I'm going to go down 1/2, down 1/2. Keep going the other direction just to fit as many dots on there as you can, but don't draw your line yet. We need to determine if it's solid or dashed. Since it is or equal to, that means some of our solutions can be on the boundary line itself. So I want to make a solid line showing that all of the solutions are going to be on one of the half planes and on the line itself because it's also or equal to. Okay, I'm going to show you my little shortcut of a way to determine now whether we shade that these are the solutions or below it is the solutions. So just read the symbol. Y is what? Y is less than or equal. Less. So look at your y-axis, look at your line where it's at on the y-axis. Where does less than that line look to you? Does it look above it or below it? Less, the word less means smaller. So I think of numbers that are getting smaller. So I'm going to shade everything below the line. So remember, this means that the solutions could be on the line itself or anything that would continue on below that. Okay, and again, if you don't believe me, let's just check. Let's pick a 0, 0. I'm not going to keep doing this, but pick 0, 0. Let's plug it in. 0 is y. 0 is also x. Okay, so this would be 0 plus 1 is 1. Is 0 less than 1? Less than or equal? Yes, it is. That means the 0 gets shaded, which is good because that's the part that we shaded, everything below. All right, cool. Number 3, it's an x by itself and a number by itself. So I hope you remember that this is going to be a vertical line. If you forgot if it's a y equals or an x equals, because we've got that on the next one, remember what I've taught you is make a quick mini table. Just make a mini table and graph them and see. This is saying x is -1, so all of the x's, make them -1s. And make y's whatever you want. I'm going to make up some easy ones. And then I'm going to go plot these. -1, 0 is here. -1, 1 is here. -1, 2 is here. So you can see it's going to be a vertical line. I almost drew a line, but you shouldn't do that because it's not a solid line. It's just greater than, which means it should be dashed. Remember, this means our boundary line will not be included in the solution set. It's only a boundary line. It's not or equal to. Okay, and now it's saying x is greater than -1. If I'm looking at my line, now I have to look either on the right of it or the left of it because it's a vertical line. Do you think greater is going to be on this side of my line or on this side of my line? I think greater is to the right because if you're thinking of a number line, that's greater. So we are going to shade the right plane, the other plane over here. And again, if you don't believe me, pick a 0, 0. 0 is greater than -1. Yes, it is, so it should be shaded. It is, because we shaded this whole half plane. Okay, number 4, a y equals is a horizontal line. Again, if you don't remember that, make a mini table and fill in all the y's as 2's. 2, 2, 2. I'm going to choose anything I want for x. 0, 2 is here. 1, 2 is here. 2, 2 is here. And I can see it's going to be a horizontal line. So when I draw it in, this time it is solid. The reason my line is solid is because the boundary line is equal to, so it could be on the boundary itself. And we are going to shade above or below. Let's read it and see. This says y is less than or equal. It's less than or equal. Less is below it. These numbers get smaller. They're less than. So shade those. Any of these would be solutions that would work in our inequality. Okay, the hardest part is when I give it to you backwards. So what we've been doing is we've had inequalities and we have graphed them. Now it's already graphed and you get to write the inequality. So it's hard to see, but this bottom part, this less than part down the number line, down the y-axis, it's less than, is shaded. This part is shaded. Okay, so I know that it's going to be something less than. In fact, that's where I'm going to start. And it's a solid line, which means that is part of the boundary itself. So that means it's going to be or equal to. Now, you're just going to write y equals mx plus b, but m is the slope, b is the y-intercept. So I'm going to start with the easier one, the y-intercept. That is at 1. So it's going to be 1, plus 1, sorry. Something x plus 1. And I just need the slope now, and we're done. The slope looks like it is up 2 over 1. Down 2 over 1. I always go a couple of them just to check. Yes, it is up 2 over 1, which is 2. So that's it. All right, let's try B. First of all, I notice it's dashed, and it's shaded below the boundary line, which means smaller or less, numbers that are less. So I'm going to do y is less than, and I'm not going to put equal to because it's not a solid line. Okay? My y-intercept hits right there at -1. And don't forget your x. And the slope that goes right next to x looks like it's up 1 over 2. Let's double check that. 1, 1, 2. Yes, it's up 1 over 2, up 1 over 2. So 1 over 2. Okay, here is, I'm glad we did one of these examples above because this is going to be an x. I almost said equals, and we're going to use the variable x because it is a vertical line. So I can see that x, I don't know why I'm writing above this time, that's okay. It's shaded to the left, which left, if you think of terms of a number line, the right gets bigger, the left gets smaller, so it's going to be everything less. It's shaded less than, and it's not a solid line, so it's not or equal to, it's just less than. Okay, what is it less than? Our line is on the 1, 2, 3, less than 3. Okay, and then the last one, it is shaded on the right side, which if you look at our y-axis means it's shaded above. So it's going to be greater. So y is greater, and it is a solid line. So that means or equal to. Okay, let's look at my y-intercept. It looks like it hits at 1, 2, 3. So it's going to be plus something x plus 3. The slope is going downhill from left to right, so please remember your negative. And it is going down 1, 2, 3 over 1, and I can only check with that 1, but it is 3 because it's 1, 2, 3 over 1. Yeah, it would be up there. So -3 x plus 3.